In order to verify that this is a probability density function, we need to say, well, over its domain, which is bigger than or equal to 0. So in other words, from 0 to infinity, if you integrate this, you will get a 1. So integrate from 0 to infinity the x times e to the negative x. So this is a good candidate for integration by parts. Let u equal x, and dv will equal e to the negative x dx. Over here, take the derivative, and you just get 1 dx. Over here, it would be negative e to the negative x. So then integration by parts would say multiply these two. So we would have the u times the v, which is going to be negative, and then x e to the negative x, minus the integral of these two, the v times du. So that's going to be negative e to the negative x dx. Oi, so much negativity. Well, notice that these negatives will at least cancel each other out. There's some positivity. And then we just need to integrate e to the negative x, which is negative e to the negative x. So we would then have it's negative x. So then it's negative x e to the negative x. These two negatives become a positive, but when you integrate this, because of that, you get another negative sign. So minus e to the negative x. And then all of that needs to be evaluated from 0 to infinity, with infinity going first. Well, notice that negative exponent actually means that you've got fractions. When this one has x going to infinity, you basically have infinity over infinity, which means you could use L'Hopital's rule. L'Hopital's rule would then say, take the derivative of this, you've got a negative 1 on top, you've got the same thing on the bottom. So this one would essentially become negative 1, and then as e goes to infinity, this gets larger and larger and larger. And if you take a negative 1 and divide it into an infinite number of pieces, each piece has a size of 0. So this is becoming 0. Likewise, this is becoming 0. What about when you substitute the 0 in? Well, this one would be 0 divided by, and e to the 0 is 1. So this is 0 over 1. So that's 0. And then this is going to be 1 on top, and e to the 0 is 1 on bottom. So that's going to be minus a 1. So this goes to 0. This goes to 0. This is already a 0, so all that's left is that negative. Negative makes positive 1. So it works. If you integrate this thing over its domain, the total is 1, which is another way to say if you add up all the probabilities, it's a grand total of 100%. Then the next part says find the probability that an x is less than 2. So that really means less than 2 would go from 0 to 2. So don't redo the same work, just go back to this right here and use the different limits. So we'd have it's negative x over e to the x minus 1 over e to the x. Evaluate from 0 to 2. So then we would have negative 2 over e to the 2 minus 1 over e to the 2. And then as we saw for this one, when you substitute 0, it becomes 0 minus 1. And so this is going to be how much? So we've got negative 2 divided by e to the 2, and then subtract from that 1 divided by e to the 2. And then this becomes a positive 1, so add to that a positive 1. So it turns out to be a probability of 0.594, or in other words, whatever this situation is, the chances or the probability that x would be smaller than 4 is 59.4%.